Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series of videos dealing with propositional logic, is going to concentrate on the evaluation of compound propositional statements when you've been provided with their actual truth values. So not the construction of the whole truth table, just the evaluation of the proposition under a particular state, if that makes sense. Just keep in mind that we have four very important connectives. We have negation, that deals with, let's say, when we have a proposition, if the proposition can either be false or true, and what negation does is it basically flips. So falses go to trues and trues go to falses. Okay? We have disjunction, also known as OR. It's a binary operator. It takes in two propositions, P and Q. All the possible states are listed here. That P and Q could be in simultaneously, and P OR with Q. Well, an OR operator only ever gives us false when both of the inputs are simultaneously false. We always have a true when either or both are a true value. Conjunction, also known as AND, takes also binary, takes two propositions P and Q. And an AND only ever gives us true when both of the propositions are simultaneously true. Okay, the implication, also a binary operator, takes in two propositions and only ever gives us false when the premise is true and the conclusion is false. Okay, so what we'd like to do is we'd like to take a proposition, a compound proposition, and we'd like to evaluate it. So, for example, let's say we have three propositions. Let's say P, and let's say P is false. Okay, let's say Q is true, and let's say, for argument's sake, let's say OR is also true. Okay, and the proposition itself that we have, the compound proposition, is that P ANDed with the negated Q, right, implies the negated P ANDed with OR. Okay, so when it comes to the implication, this is the premise over here, and this is the conclusion over here in the brackets, just to make sure that there's no ambiguity. The premise is an AND. Okay, the AND has a left operand, it has the P proposition, and then it has a right operand, which is a negated Q. Okay, the conclusion, the left operand on this AND is a negated P, and we have a negated OR. And then we have an OR as the right operand. So what we're going to do is we're going to do substitution. Everywhere we see a P, we're going to put in an F. Everywhere we see a Q, we're going to put in a T, and everywhere we see an OR, we're going to put in a T also. So this proposition now becomes false ANDed with Q is true, but that needs to be negated, and that implies P is false, which needs to be negated, ANDed with OR, which is true. So this was just the first step, is just a substitution. Okay, we're substituting in the actual state of the proposition that has been given, okay, into the compound proposition, and now we start our evaluation. So what we're going to do now, so this now is basically equal to, so what we're actually going to do is, before we can do this, and before we can do the implication, we have to evaluate the whole left hand operand down to a single truth value, which you can see it's not. And also, before we can do the implication, we have to evaluate the right hand, or the conclusion, down to a single truth value, which this isn't. But when we look at the premise, the premise is made up of an AND, and to evaluate an AND, we need two truth values. Now, we have the truth value as a false statement, false, on the left hand side here, but on the right hand side we have a negated T. So what we need to do is we need to negate the T first of all. So we know the way a negated true value, okay? A true being negated goes to false. So this now becomes false needs to be ANDed with false, okay, because the true negation went to false, which implies, and this false value here needs to be negated, so this becomes true ANDed with true. Okay. Now we know the way an AND works. An AND only ever gives us here's the AND here. An AND only ever gives us true, and both of them are true. In this case, we have two falses, so the output from an AND is false. So this reduces down to be. False. Implies, well, true ANDed with true is always true. Okay, so now we have false implies true, and then this. But these are sort of equivalent. So this here, okay, then reduces false implies true. Well, look at the implication. when is the premise false in these two cases here, and when is the conclusion true right here. So in this state here, we get a true. So this implication is actually true. Okay. Let's have a look at another example. Okay. So let's say we have something like p. Let's say ORed with p bar all negated. Okay. And that needs to be ANDed with. Okay. Let's say p bar implies, let's say, q or not q or q. Okay, let's say something like this. Okay, and we want to evaluate this particular compound proposition. Okay,